Hey everyone, and welcome back to The Explainer. Today, we're diving into a concept that fundamentally shifts how we need to look at artificial intelligence in the enterprise. We are unpacking the energetic paradigm, or EP, and specifically its core investable function, boundary formation. We're going to figure out why this isn't just some abstract philosophical idea, but a rigorous, absolutely crucial infrastructure capability that's ready for the real world right now.
So I want to start by asking you a question. Think about your own systems for a second. Why does complex AI work fail in the enterprise? It's incredibly frustrating, right? You have these massive systems that can generate beautifully fluent, persuasive text. But the moment you drop them into a high-consequence environment, where absolute accuracy and structural discipline are non-negotiable, that fluency completely falls apart. It just fails.
Okay, let's dive right into this. Here's our roadmap for today. We'll start with the uncontrolled AI problem, define boundary formation, and then explore market demand, operational execution, scalable architecture, and finally wrap it up with the investor takeaway.
Section 1. The uncontrolled AI problem and the true cost of AI drift.
Think about casual AI for a moment. It's totally fine with loose reasoning, stylistic editing, and just generating persuasive text. But enterprise EP, that is an entirely different beast. Serious workflows like complex legal reviews or heavy financial analysis, they cannot survive on persuasive text alone. They demand strict structural rules, full auditability, and controlled deduction. Instead of asking if a model can just say something plausible, we really need to ask if it has the underlying structure required to be absolutely reliable.
Because when that structural reliability vanishes, we get what's known as AI drift. And we've all seen this. An intended investor memo inexplicably drifts into a rambling general essay. A precise contract review turns into basic, totally unhelpful style editing. Or an AI governance request spits out ethical slogans instead of hard operational rules. This drift isn't just some quirky AI hallucination. It is a massive commercial failure that happens the literal second explicit boundaries are absent.
All right, Section 2, defining boundary formation and what this function actually does.
So what is it exactly? Well, boundary formation is an operating capability defining exactly what belongs inside a task, claim, system, or evidence set, and, this is the crucial part, what must remain outside. This is powerful stuff. It takes the hazy, abstract weakness of AI hallucination and transforms it into a concrete, investable, operational gatekeeper. In practice, this operates across 3 distinct phases to control the flow of AI generation. Before it even begins, it frames the task. During generation, it's actively checking the work, and after, it judges the final output strictly against that predetermined structure, not just its writing style. It completely changes the entire lifecycle of the task through explicit, hard decision gates.
Moving on to Section 3, market demand and the absolute need for reliability.
The commercial drivers here are frankly huge. AI is rapidly moving out of casual conversation and straight into high-liability, serious work. Buyers don't want more persuasive text anymore, they need structural reliability. These AI outputs have to survive brutal reviews by decision-makers, lawyers, engineers, and investors. Institutions absolutely must reduce drift and contradiction before they turn into actual business risk, costly delays, or real liability. So the bottom line is this. As AI deployment deepens into high-value workflows, the cost of uncontrolled generation drastically increases. The market doesn't just want boundary formation, it literally needs it to survive.
Which brings us to Section 4, operational execution under pressure.
Now, what's really interesting here is looking at the operational difference in action. With ordinary AI, the reasoning is hidden deep inside fluent language. Evaluation is based almost entirely on style, and failures, well, they're just quietly edited away. But with EP boundary operations, the reasoning path is fully inspectable and evaluated structurally. When a failure happens, it isn't just hidden, it's explicitly classified and used to improve the next execution cycle. It exposes the real object of the work.
And this is where the function becomes truly operational. EP makes the boundaries completely visible right at the start of the work. It explicitly defines the object, the scope, the inputs, what is definitively excluded, the required proof threshold, and the clear rejection conditions. It acts as a definitive quality gate. It tells the system exactly what it must do, what it must reject, and what must happen when an output fails to meet the structure.
Section 5, scalable architecture and the path to a real product.
Now you might be wondering, how does this scale? Scalability for EOP does not mean claiming to solve every problem in the universe. Actually, scratch that. That would just be more uncontrolled expansion. Instead, true scalability means preserving the exact same operating logic under entirely different task pressures. The surface content might change. You might move from reviewing a dense legal contract to organizing a complex research pipeline. But the core structural failure is controlled in the exact same predictable way every single time.
Because this operating logic is so incredibly consistent, it becomes a powerhouse repeatable module across the entire enterprise landscape. It can standardize task intake and client discovery, embed straight into document intelligence and enterprise copilots, or even power complex agent orchestration and strict governance systems. It's a unifying standard across entirely different forms of work, providing a clear, proven path toward real productization.
Finally, Section 6, the investor takeaway and the core value proposition.
And this brilliantly illustrates the triad of EP's traction. We have demand, driven by the real market pain of failing, uncontrolled AI. We have execution, driven by a method that operates perfectly inside real tasks. And we have scalability, driven by repeatable product logic. Boundary formation is the vital connective tissue here, linking a recurring AI failure directly to an investable, highly repeatable EP capability.
To tie this whole thing together, there is a line from the source material that just absolutely hits the nail on the head. It says, EB should not be evaluated as another content tool. It should be evaluated as a system of functions that make AI work more controlled, deductive, auditable, correctable, and operationally useful. It's the ultimate evolution from uncontrolled, chaotic generation to disciplined, trustworthy intelligence.
So, as we wrap up this explainer today, I have one final, pretty important question for you to consider about your own organization. Can your current AI infrastructure actually survive high-consequence deployment without boundaries? If you're relying on ordinary AI, the answer is likely no. The energetic paradigm is the structural control layer that makes the future of enterprise AI possible. Thanks so much for joining me today, and keep exploring those boundaries.